All right, so this is the first of 2 lessons looking at what we say are factoring trinomials. A trinomial is a polynomial with 3 terms. And so, for example, what you see right here, x squared plus bx plus c, is an example of a trinomial. And so how do we factor trinomials like this? And so when I say like this, I mean 3 terms. And the key thing today is that most of the time there will be no coefficient in front of the x squared, which means there's like a 1 right there. If there is a coefficient in front of there, we'll talk a little bit about that today. But especially as things get more complex, we need a separate lesson for that. So in general, if you want to factor something like this, you are trying to unfoil this. You're trying to think about what 2 factors multiply together. And so if you were to foil it, 1, 2, 3, 4 steps, that would bring you to here. So going this way is foiling. Going this way is factoring. And so how do we factor something like this? Well, I'll kind of tell you the idea, but more importantly, we just need to kind of try it. In general, we need to pay attention to the coefficient of x and the constant at the end. And the first thing we want to do is pay attention to the constant. And here it's a c. And it may be a negative number. I just put plus c, but it can be any number. And what we need to do first is think about our times tables. And this is where you need to, you need to know your times tables. Even using a calculator doesn't help. We need to think about 2 numbers, or really 2 integers. We need to find 2 integers, and integers maybe are negative numbers as well, that multiply to c. So whatever number is there, we need to think of 2 numbers that multiply to c. Oh, sure. That said, at the same time, we need to think of 2 integers. And again, integers are positive or negative whole numbers that add to b, whatever that b value is, whatever the coefficient of x is. And whatever those 2 integers are, those are the numbers that go here and here. So if those 2 integers are 2 and 3, it's going to be x plus 2 and x plus 3. But there has to be 2 integers, the same 2 integers, that multiply to c and add to b. That's it. Honestly, I just need to give you some examples. So here's several examples. I don't need a lot, but in each of these are fairly quick. So I want to factor this. So what I need to do first is pay attention to the 27. And I need to think of 2 numbers that multiply to positive 27. Okay? I also need to think of numbers that add to 12. But first, let's start with what numbers multiply to 27. So there's a fair amount of choices. But one thing that jumps in my head when I think of 27 is 9 times 3. And notice 9 and 3 multiply to 27. 9 plus 3 also adds to 12. So I know my factors are going to have a plus 9 and a plus 3 here. And so since my variable here is x, I know my 2 factors must be x plus 9 and x plus 3. And I factored it. And I knew it was plus 9 and plus 3 because I was paying attention to first what numbers multiply to 27, and then just checking if those 2 numbers also add to 12. And that's it. I mean, it's quick. And if you know your times tables and you're good with your mental math, it is very, very quick. If you struggle with this, it's probably down to not knowing your times tables so well. And if you ever are unsure, again, if you FOIL this all out and collect like terms, you will get this. All right, that's it. Let's look at this one. I want to factor this. I know my factors are going to be of the forms x plus or minus some number and x plus or minus some number. First, let's look at negative 27. What 2 numbers multiply to negative 27? Well, for example, negative 9 and positive 3 multiply to negative 27. But if I add these 2 together, negative 9 plus 3, that doesn't add to 6. Negative 9 plus 3 adds to negative 6. OK? So let's try 2 different numbers. And I may just have to change the signs. In fact, if I change this to a plus and this to a minus, it still multiplies to negative 27. Positive 9 times negative 3 still multiplies to negative 27. But notice positive 9 plus negative 3 is positive 6. And so my 2 factors must be x plus 9 and x take away 3. There's always ever one pair of correct answers. Or the other option is it cannot be factored. But if you can factor it, there's just going to be one correct possible pair. So here, similar again. I have, again, x squared minus 6x minus 27. I need to think of 2 numbers that multiply to negative 27, but add to negative 6. So almost the exact same thing as last time. Just this time, it's going to be minus 9 and positive 3. Because notice negative 9 plus 3 is negative 6. Negative 9 times 3 is negative 27. And so it's going to be x minus 9 and x plus 3. All right, so honestly, no, not that that covers everything, but that does cover the basics of this. And so I want to look at some slightly different looking examples. But mostly, we just need practice with this. All right, so next, x squared minus 12x plus 20. I need to think of two numbers that multiply to 20 and add to negative 12. Well, when I first think of what numbers multiply to 20, I first think of 5 and 4. Unfortunately, I can see there's no way I can make 5 and 4 add to 12. So let's think of something else. What else multiplies to 20? Well, how about 2 and 10? Okay, 2 times 10 multiplies to 20. How can I make them also add to negative 12? Well, I can do that if they're both negative. If they're both negative, negative 2 times negative 10 is still 20. Negative 2 plus negative 10 is negative 12. So my two factors I can see are x minus 2 and x minus 10. And let's look at this one. Now this is almost the same thing, except it has these y variables in it. And so notice, though, how similar this and this are. And the only difference, again, is that this expression here has x and y. Well, I will say it's the same coefficients. It's that same negative 12, that same positive 20. So I will say these two will have very, very similar factors. In fact, they're so similar, I'll write them down. X minus 2 and x minus 10. The only difference is that this will also have a y here and here. And again, if that seems kind of surprising, well, let's FOIL this out. X times x is x squared. X times minus 10y is minus 10xy. Negative 2 times x is negative 2xy. Put these together, you get negative 12xy. And my last step, negative 2y times negative 10y is positive 20y squared. And so not that I really want you to FOIL this every single time, but if you're ever unsure, or if you have to make a guess, you can always check. And the last one is, again, it's different but similar. The difference here is that we have x to the power 4 and x squared. But again, I have the same coefficients of negative 12 and 20. So I will say again, the factors here will be very similar to the first one, x minus 2 and x minus 10. The difference here is when I FOIL it out, it has to get to x to the power 4, which means each of these must be squared. X squared minus 2, x squared minus 10. And again, I appreciate if you look at this and that seems a little strange, or if you're unsure, fair enough. Notice if I were to multiply, the first thing would be x squared times x squared, which is x to the power 4. And then x squared times minus 10 is negative 10x squared. And then negative 2 times x squared is negative 2x squared. Put these together, combine like terms, you got negative 12x squared. And so like I said, I don't want us to really FOIL every time because that just takes too long. But if you're ever unsure, and these are some trickier examples, you can always double check. All right? And so with that, I have one last trio before a final problem. And similar to before, these are all related to one another. So let's look at the first one. X squared plus x minus 56. So here, I got to find two numbers that multiply to negative 56 but add to 1. And so what multiplies to 56? I think of 7 and 8 multiply to 56. It's got to multiply to negative 56. So one of these has to be negative, one has to be positive. Well, if it's going to add to positive 1, that will work if I make the 8 positive and the 7 negative. Notice if I have negative 7 times positive 8, I get negative 56. Negative 7 plus 8 is positive 1, which means I know my factors are x minus 7 and x plus 8. OK, so somehow that connects to the next two. So how is that going to happen? Let's look at the next one. The next one seems distinctly different. But one thing I hope you notice is that for the first time today, there's a coefficient in front of the x squared. Well, if there is a coefficient in front of the x squared, the first thing you want to check is there a GCF that you can factor out of all of these? And there is. If you look at all of these terms here, they have a GCF of 2. All of these terms can be divided by 2. So let's look and build upon what we did last lesson and start by taking out a factor of 2 from all of this. If I take out a factor of 2 from all of this, that means I divide all these terms by 2. And so I have just x squared plus 1x minus 112 divided by 2 is 56. And now everything you see right here is identical to what we did right here. So I don't really have to do these steps all over again. I already know that x squared plus x minus 56 factors into this. So I can then finish this last step off right here by saying 2 times those same two factors, x minus 7 times x plus 8. So notice this particular trinomial ends up with 3 factors. And yes, most of what we're looking at today ends up with 2 factors, but this has 3. 2 is a factor, x minus 7 is a factor, x plus 8 is a factor. And again, all 3 of these all relate somehow back to this one right here. So if I look at the last one, I can see the 56, the negative 56 in there, but I have x cubed, so it seems kind of strange. But if I look at this, what I can do is check for a GCF, because it is kind of weird. There's a power of 3 right there. But notice I can take out a GCF of x from all of these. All of these can be divided by x. And so if I take out a common factor of x from all of these and write that first, I have x times x squared plus x minus 56. Again, every time we pull out a factor, we end up dividing each of the terms by that factor. And if I divide each of those terms, x cubed, x squared, minus 56x by x, you get what I have in the brackets. And now notice what I have in the brackets is, again, the exact same thing I've seen in the last few questions, x squared plus x minus 56. It's literally all highlighted in green. And so I don't need to redo that all from scratch again. I know that what's highlighted in green is x minus 7 times x plus 8, and there's also this factor of x. So this question also ends up having 3 factors. And so these last few questions are the most challenging for sure, and it's because you have to connect back what we saw last day about looking for a greatest common factor with what we learned today. And those are always the most challenging, but also the most important questions, ones that connect different things together. And in general, always look for a GCF right away. Anytime you have to factor, and there's still 2 more lessons of factoring after this, anytime you have to factor, always look for a GCF right away. And if there is a greatest common factor, factor it out, and then see if there's more you can do. That's it. I have a final problem, again coming back to some areas of rectangles. And so for each of these, again, I want to try to find a possible length and width that will bring this, that lead to this area. So let's look at this first one. The area of the rectangle is x squared plus 14x plus 24. So what is a possible length and width? Well, that means I'm really asking what are the factors of x squared plus 14x plus 24? Well, we've just learned how to factor things like that. So the factors of that I know I could find by seeing what multiplies to 24 and adds to 14. So what multiplies to 24? I first think of 6 and 4. I can't make 6 and 4 add to 14. So what else multiplies to 24? 8 and 3. I can't make 8 and 3 add to 14. Is there anything else? Yeah, there's 2 and 12. 2 times 12 is 24. And 2 plus 12 is 14. Which means I can see the 2 factors would be x plus 2 and x plus 12. Which means now that I factor this and erase all my mess, I could say, the distance across the top is x plus 12, and the height of this is x plus 2. So I can think of it like this. X plus 12, x plus 2. Okay, and notice if I then looked at these little quadrants here, this would be x squared, this would be 12x, this would be 2x, and this would be 24. The individual areas there. Add it all up, you get back to what I started. Okay, so how could we do this one here, where there's a 2 in the front? Well, unfortunately, unlike the last few examples before this question where we had a coefficient, I can't factor out a 2 from all these. 7 and 3 are not even numbers. I can't take a factor of 2 out of that without creating fractions or decimals. So what can I do? Well, if I start looking for 2 numbers that multiply to 3 and add to 7, that won't work because there's a 2 there. Everything we talked about only makes sense if there's a coefficient of 1 in front of x squared. If I go back to how I generalize things right here, notice the very beginning, there's a 1 right there. If there's a 1 right there, which you don't have to draw, then yeah, everything I have here is true. If there's not a 1 there, this is not true. So how on earth can we factor this? Well, we really have two things we can do. One is to put it on hold until the next lesson, or kind of do a bit of, I guess and check, and kind of just try some different factors. But in the end, I will say what will work, and the only thing that will work is having 2x plus 1 here, and x plus 3 here. And notice I can show it works by, if I multiply these together, 2x times x is 2x squared. 1 times x is x. 2x times 3 is 6x. And 3 times 1 is 3. Combine like terms. I have 2x squared. I have x plus 6x is 7x. And then a 3 right here. So my length and width are 2x plus 1 by x plus 3. But like I said, how can I do that without just guess and check? Well, that's what the next lesson is about. So the point of this is it is definitely possible to factor 2x squared plus 7x plus 3. And I can see the factors must be 2x plus 1 times x plus 3. But again, at this point, your only option is really guess and check. Try some different factors. If it works, great. If not, try something else. But that's obviously going forward not the best approach. And so that's why we have another lesson on how to factor trinomials. And it's how to factor stuff like this without just guess and check. All right? So I think it's a good time to stop.